formation of cations present in a given salt using the reagents like sodium hydroxide and ammonium hydroxide. So let's see the first cation, that is calcium ion. Right, so first we are testing calcium ion with sodium hydroxide. When you take the salt solution which contains calcium salt, and when you add small amounts of sodium hydroxide, it forms a white precipitate. And this white precipitate is insoluble in excess sodium hydroxide solution. So calcium salt solutions will produce a white precipitate with sodium hydroxide, and those white precipitates are insoluble in excess sodium hydroxide. Then the same calcium salt, when treated with ammonium hydroxide, there won't be any precipitate. Ammonium hydroxide does not give any precipitate with calcium salt solutions. So calcium salt solutions will give precipitate, that is white precipitate, only with sodium hydroxide but not with ammonium hydroxide. And the next cation is cupric ion, that is Cu+2. And when you take copper ion solution, copper salt solution, and to that when you add small amounts of sodium hydroxide, it forms a pale blue precipitate. Pale blue precipitate is obtained when you add small amounts of sodium hydroxide. And when you add excess sodium hydroxide, this pale blue precipitate remains pale blue, that means it is insoluble and remains pale blue. So copper ion solution, that is Cu+2 ion, will give you pale blue precipitate with sodium hydroxide in small quantities, and it remains pale blue only when you add excess sodium hydroxide as well. Next one, the same copper ion testing. When you add small amounts of ammonium hydroxide to this copper ion solution, it gives a pale blue precipitate. It gives a pale blue precipitate. And to this pale blue precipitate, when you add excess ammonium hydroxide, now this dissolves in that excess ammonium hydroxide and forms inky blue solution or deep blue solution. It forms because that pale blue precipitate is soluble in excess ammonium hydroxide. So copper ion salt or Cu+2 salt solution will give you pale blue precipitate with both sodium hydroxide and ammonium as well. But this pale blue precipitate is insoluble in excess sodium hydroxide, but it dissolves and forms dark blue solution in case of ammonium hydroxide. So that is the confirmatory test for copper ion in the salt. Next, moving to zinc ion. Now this zinc ion solution, or when you take a salt solution which contains zinc ions, and when you add small amounts of sodium hydroxide, it gives gelatinous white precipitate. And this gelatinous white precipitate is soluble in excess sodium hydroxide. So we will get a colorless solution with excess sodium hydroxide when zinc ion is present in the salt solution. Then the zinc ion can be tested with ammonium hydroxide as well. Now, even with ammonium hydroxide in small amounts, this zinc salt solution will produce gelatinous white precipitate. And this gelatinous white precipitate is soluble in excess ammonium hydroxide. That means zinc salt forms gelatinous white precipitate both with sodium hydroxide and ammonium hydroxide, and in both the cases, means in excess sodium hydroxide and in excess ammonium hydroxide, in both the cases that gelatinous white precipitate is soluble. So that is a test for zinc ion. Then test for lead ion. So now this lead salt solution, when treated with small amounts of sodium hydroxide, it forms chalky white precipitate or simply white precipitate, which is soluble in excess sodium hydroxide. So lead salt solution gives a white precipitate with small amounts of sodium hydroxide, which is soluble in excess sodium hydroxide. The same lead salt solution will give white precipitate again with small amounts of ammonium hydroxide, but this remains insoluble in excess ammonium hydroxide. So lead salt gives a white precipitate which is soluble in excess sodium hydroxide, and the same lead solution will give you white precipitate which is insoluble, which remains insoluble in ammonium hydroxide. Then that is the test for lead ion. Then ferrous. So for ferrous ion, you just need to remember the color of the precipitate. So whether you add sodium hydroxide or ammonium hydroxide, in both the cases, the precipitate is dirty green precipitate, and in both the cases, the precipitate remains insoluble. Whether you take excess sodium hydroxide or whether you take excess ammonium hydroxide, in both the cases, it remains insoluble. So for ferrous ion, you just need to remember the color of the precipitate, that is dirty green precipitate, and in both the cases it remains insoluble when you take the both reagents in excess. Then next one is ferric ion solution. Now even here you need to remember the color of the precipitate. For ferric ion, you need to remember reddish brown precipitate in both the cases, whether it is sodium hydroxide or whether it is ammonium hydroxide, and in both the cases it remains insoluble. In excess sodium hydroxide it is insoluble, and in excess sodium hydroxide and ammonium hydroxide as well it is insoluble. So for ferrous ions, just need to remember it is green dirty green precipitate, and for ferric ion reddish brown precipitate. So this is the test for ferric ion. Test for ammonium ion. So here for testing ammonium ion, you need to take a reagent called Nessler's reagent. So when any salt solution which contains ammonium salt and it is treated with Nessler's reagent, then the solution turns brown color and finally it forms dark brown precipitate. So this is a test for ammonium cation. And if any salt contains ammonium ion, and when it is heated with sodium hydroxide, concentrated sodium hydroxide, it releases ammonia gas, and that ammonia gas gives dense white fumes with the glass rod dipped in concentrated HCl. Right, so this is the confirmatory test for ammonium cation. So this is how we can identify the presence of cations present in the given salt solutions. So for ferrous and ferric, you just need to remember the color. For ferrous, it is dirty green, and for ferric, it is reddish brown precipitate. Then for lead ion, in both the cases, you will get white precipitate or chalky white precipitate, and this lead ion white precipitate is soluble in excess sodium hydroxide. It is soluble in excess sodium hydroxide but remains insoluble in ammonium hydroxide. And the next one is zinc. Zinc will give you gelatinous white precipitate with both the reagents, and with both the reagents it is soluble. That is sodium hydroxide and ammonium hydroxide, both the reagents in excess. The zinc gelatinous white precipitate is soluble. And for copper, copper gives with both sodium hydroxide and ammonium hydroxide, pale blue precipitate and pale blue precipitate, and the solubility, it is soluble in excess ammonium hydroxide but insoluble in excess sodium hydroxide. And calcium ion does not give any precipitate with ammonium hydroxide, no precipitate with ammonium hydroxide, but it gives white precipitate with sodium hydroxide, which remains insoluble even in excess sodium hydroxide. So these are the cations you have to learn for the exam. So total 7 cations are there, and definitely you can expect 2 marks or maximum 3 marks from this cation analysis.